All right, this is problem 3. My name is Adam Dietrich. Here's my Bearcat card, and this is project 2. Let's get right into it. So this is the original problem we're given. It has two variables, so it's a multivariable equation, and we're asked to find the partial derivatives of f sub x and f sub y. So firstly, we're going to look for where the x's are. 2x squared becomes 4x based on our derivative rules that we know, and negative 4xy becomes negative 4y. For f sub y, we're going to ignore this because there's no y's in it. We're going to start here. This is going to become negative 4x, and this is going to be 3 times 1/3, which is 1, and then reduce the y squared. And then finally, negative 5y is just going to become negative 5. All right, for part B, we have to find all the critical points of f. So there's two equations, two partial derivatives. We're going to choose one of them. For this, we chose f sub x equals 0. And we're going to try to solve for one of these variables. So I chose to solve for x here. And as you can see, x equals y, meaning wherever there's going to be an x, we're going to replace that with a y. And we're going to do that with the f sub y equation up here. As you can see, right here, we replace that x with a y. And now we're going to put that into solver and figure out what the variable actually is. So we come out with y equals negative 1 and 5. Now, the next step is taking these numbers that we found for y, and plugging them into the f sub x equation, and using solver after we set those equal to 0 to figure out what the x variable is. And we come out with x equals negative 1 and 5, which is interesting because up here we found earlier in the problem that x equals y. That rings true. Therefore, there are two critical points, one at negative 1, negative 1, and one at 5, 5. All right, this is part C, which is asking us to find the second partial derivatives. It's pretty easy because it's just asking us to find the partial of a partial derivative. So let's start by looking at the x equation to find the partial with respect to x of this equation, which is just going to be 4 because you're multiplying 4 times 1 and that x reduces. So it's just going to be 4. Let's take a look at, for this one, we're going to look at the f sub y equation. We're going to solve with respect to y, which is y squared, multiply the 2 by the 1 that's out front, 2y to the first, because that y reduces. That's just going to be 2y. Then f sub yx, we're going to look at the y equation and solve with respect to x for the derivative. And that's just going to be negative 4. And as we know, based on what we know of partial derivatives, f sub xy and f sub yx are going to be the same always. All right, this is part D, and it asks us to classify the critical points according to the determinant test. So, the determinant test formula. This is pretty essential. I have it written down here, but basically we're going to take these numbers we found up here and plug them into the determinant test formula. And what you get is this. And what's interesting about it is there's a variable here. So we can't just find a number right away. We have to use our critical points here and plug those into wherever there's a y. If there was an x, we'd plug it in where there's an x as well. So when we do that, we plug in negative 1 for y here. We get d equals negative 24. As we know, whenever the d value is less than 0, it's a saddle point. Here we get d equaling 24, which is greater than 0, which means it's going to be a relative extrema. And we don't know quite yet whether it's a min or a max. We have to find that out based on whether or not f sub xx is positive or negative. In this case, it's above 0, so that means it's a relative minimum. So we have a relative max nowhere. We have a relative min at 5, 5, and a saddle point at negative 1, negative 1.